This one said the points 1, 2, 2, 5, 3, 2, 4, -1, and 5, 2 are on one cycle of a sine wave. And if you want to see what the graph of that would look like, here you go. Again, here are the points 1, 2, 2, 5, 3, 2, 4, -1, and 5, 2. So first thing, let's find amplitude. Again, your point or your equilibrium, your rest line, from that line, what's my amplitude? 3. The height from here up to the top of the graph is 3. Next, let's find the period. How long it takes for it to repeat, and I see that from here to here, it starts repeating again. So what's my period? 4. Everybody understand that? So to find my B term that's going to be in my equation, period is equal to 2 pi over B, or you can say B is equal to 2 pi over the period. So somebody clean that up for me. 2 pi over 4 is going to be pi over 2 again. So my B term in my equation is going to be pi over 2. So now my sine equation looks like this. Y equals 3, your amplitude times the sine of x. But since our B term is pi over 2, it's going to be the sine of pi over 2. That's our compression factor. X, and then we're going to plus and minus something to get to this point. Again, normally, think about how your graph looks. Here at 0, 0, it starts going up and then it comes back down. Similar to right here. See how it starts coming up, goes back down. Okay, normally this was your 0, 0 point, or you could say normally this was your 0, 0 point, it got shifted way over here. Or you could say there's going to be more points back here you could use. There's going to be a point every 4 units that you can use there because that's the period. So if we use this 1, 2, this graph got shifted right 1. So what do we put with our x? And what do we tack on the end? Plus 2. What used to be at 0, 0 is now at 1, 2. So there's the equation of that graph. And again, you can always check that by graphing it using your graphic calculator, using the trace function and seeing is 1, 2 on there, is 2, 5 on there, is 3, 2 on there. Okay.
How do you find the
How long it takes for it to repeat. You can use the crest or the troughs, like right here. You could use this point and just count over 1 unit, 2 units, 3 units, 4 units. How long it takes for that graph to repeat. Which I use those equilibrium points, those middle points. Which I made up that term. That's not an extra. You're not going to see that equilibrium points term in a book or anything. I just made it up. Here's your tangent graph. We've done our sine and cosine. Y equals tan of x, and we've already looked at it once. But period of tangent, this is important. Write this down somewhere. The period of sine and cosine was 2 pi. Tangent's not the same. If you look at this graph, you've got one complete cycle here, and then that cycle starts over right here. From here to here to here, that would be period skips there. This is negative pi, this is 0, this is positive pi, this would be 2 pi, 3 pi, and so on and so forth. The period of the tangent function is actually pi, or 180 degrees. It repeats every 180 instead of every 360. Amplitude, not applicable. It doesn't have an amplitude. It doesn't have a height. Domain. Notice what we did here on domain. Again, when you list domain, you can either list the things that x is or the things that x can't be. And here we listed the things that x cannot equal. X cannot equal negative 270, negative 90, 90, 270, 450, 630. And notice that's every 180 degrees. Because every 180 degrees, think about what cosine does. Tangent is equal to sine over cosine. Anywhere cosine is 0, then you're going to have an undefined function here. Let's talk about everywhere that cosine is 0. The best way of doing it is think about your unit circle. Cosine is the same thing as an x value on your unit circle. Here my x value is 0, here my x value is 0. So every 180 degrees you get that 0 for an x value. So that's the reason that tangent has that asymptote line every 180 degrees. So anywhere, and we're okay at 0. Cosine of 0 is 1. We're all right there. But it's what happens pi units, or excuse me, pi over 2 units, pi over 2 units later, 90 degrees later. That's where it hits that cosine of 0. The range, all real numbers. Because, again, your asymptote line, that thing follows it, keeps going up higher and higher and higher, so all real numbers from negative infinity to positive infinity. That's your domain and range there. Sketch 2 cycles of the function y equals tan 2x and determine the period. And you can sketch it if you want to. Here's the actual, and the way you would sketch it, you know your table of values. You know the tangent of 0 is 0. The tangent of 30 degrees is square root of 3 over 3. The tangent of 45 degrees is 1, and so on and so forth. You know how to sketch it there. Tangent of 2x, though. Before the period of regular tangent was what? What did I say period was for tangent? Pi. As soon as you multiply that x value by 2, that's a compression. That's a horizontal compression times 1/2. So what used to repeat every pi units is now going to repeat every pi over 2 units. That's the new period. That's all it says to do there. Sketch it, determine the period. What else would that change? That 2 right there. What else would that change? Would it change your range? No. It doesn't have an amplitude, so I don't think it'll change it. Would it change the domain? Yes. Because before we couldn't equal 90 degrees, but that thing got stretched in, right? Here's 90 degrees, by the way, right there. It's equal to 90 here. Because if you plug in 90 degrees there, you've got the tangent of 180, we're fine. But when you did that compression times 1/2, it took that 90 degrees that it couldn't equal before and it changed it to 45. So now it can't equal 45, and then every pi over 2, you're going to have that same repeat. So can't equal 45, can't equal 135, can't equal 225, every 90 degrees now. Let's move on. Let's skip over that. The other three. Reminder that cosecant is the inverse of sine. Secant is the inverse of cosine, and cotangent is the inverse of tangent. We did that earlier in the chapter. What we're going to do now, we're going to go through and remind you how to find secant, cosecant, cotangent. And then we're actually going to graph these three. We're not going to go through all these, but let's do a few of them. These are not your common ones, right? Cosecant of 54, if you want to find out what the cosecant of 54, you would type that into your calculator. Since cosecant is the reciprocal of sine, you would type it in as 1 divided by the sine of 54. The secant of 31.5, you would type in as 1 divided by the cosine of 31.5. And let's just do, one of these down here. The cotangent, you would type in as 1 over the tangent of 3 pi over 8. And as you type that in, just make sure you're in radian mode. The first two problems up there was in degrees, but make sure as you type in that 3 pi over 8, that's the tangent of a radian answer or a radian angle, so make sure you're in radian mode when you type that in. Now let's try these just for extra practice. The cosecant of 240, the secant of 750, I'm not going to give these to you on your quiz, but you can do these in your head. Let's try to do these without a calculator. The cosecant of 240 is the same thing as 1 over the sine of 240. And we know how to find the sine of 240 by using reference angles. Let's see, the sine of 240, let's first determine is that positive or negative. And again, you can use all students take calculus. All students take calculus. What quadrant is that? Third, so it's going to be negative. And I'm just going to put my negative out front. The sine of 240 has a reference angle. Okay, this was 180. And we're always determining how far, to find your reference angle, how far are you from the x-axis? How far are you from 180? How far are you from 360? We're closer to 180. How far away from 180 are you? 60 degrees. So let's find the sine of 60, which would be, so 1 over root 3 over 2. To divide two fractions, you flip the second one and multiply, so that would be negative 2 over root 3. Rationalize by multiplying top and bottom by root 3, that'd be negative 2 root 3 over 3. That's the exact value of the cosecant of 240. Secant of 750. Let me erase that so I have room. The secant of 750 is the same thing as 1 over the cosine of 750. Now I notice 750, we normally deal between 1 and 360, so 750 is way too big, so find coterminals. Take off some rotations there. It's going to make it easier. How many rotations can we take off? How many? Just 2. Take off 720 degrees, and we're now at 1 over the cosine of 30. 30 and 750 have the same terminal side. They're going to have the same sine, cosine, and tangent, so we're good there. And we don't even have to find a reference because we know the cosine of 30 is also root 3 over 2. So nearly the same answer, isn't it? Flip and multiply, that'd be 2 over root 3. Rationalize, that'll be 2 root 3 over 3. Let's skip down here and do this middle one. The cotangent of negative 5 pi over 3. First thing, let's change it to degrees, but at the same time, we could, I guess, flip it. That's 1 over the tangent of negative 5 pi over 3. Negative 5 pi over 3. So we change that. 180 is pi. Divided by 3, multiplied by 5, that's negative how many degrees? Negative 300 degrees. And I would actually, again, if you want to use negative 300, if you want to try to find your reference angle there, that's fine. I would do coterminals. I would add a rotation on just to make it positive because I don't really want to deal with negatives. So let's do 1 over the tangent of, add a rotation, negative 300, same thing as what? 60. And the tangent of 60 is root 3. I didn't have to worry about positives, negatives there because both of those were first quadrant angles. 1 over root 3 rationalized is root 3 over 3. Here we see the graph of y equals the cosecant of x. And let's talk about why it looks the way that it does. If you took your sine curve, there's your sine curve. If you took your sine curve and take these values, like we know that the sine of 30 degrees is a half. Well, cosecant is the reciprocal of that sine. Okay, which by the way, cosecant will have asymptote lines. Does everybody understand that? Since cosecant is 1 over sine, anywhere the sine is equal to 0, you've got an asymptote line. Sine is equal to 0 at 0. So you see that asymptote line? The sine of, what else is 0? 180. So you see what you're going to have as far as the period here. The period for cosecant and secant is the same thing as period for sine and cosine. The period for cotangent is the same thing as period for tangent. They're similar graphs. So here we have a period of 360 degrees. It doesn't repeat until here. The same way the sine repeats over that interval, cosecant comes up here, down here, and then would go back up here again, every 360 degrees. But take that sine of 30 equal to half. Well, to find the reciprocal of that, 1/2 now changes to 2. As your values get bigger and bigger and bigger, if you divide 1 by bigger and bigger and bigger things, it gets smaller and smaller and smaller. 1 divided by smaller things is bigger. So that's the reason it kind of flips that graph over. Kind of. The sine of 90 degrees was 1. When you flip 1, you get 1. So that's the reason they actually touch there. So you see there the basic form of your cosecant graph. And we already know the secant graph is going to look very similar. Your secant graph, and here's your cosine graph to go along with it. Your secant graph simply flips over that cosine graph. Secant is 1 over cosine. Look at the difference between tangent and cotangent. The red is your tangent graph. The blue is your cotangent graph. Same thing. You're flipping. Okay. You have a zero tangent here, so you're going to have an asymptote line there. Have a zero tangent here. Same thing. You're going to have an asymptote line. But your cotangent graph is simply your flip of your tangent graph. Well, you see that symmetry there. You see that mirror image. There we go, just working a couple of these. Sketch 2 cycles of the function y equals 0.3 cotangent 2x plus pi over 2. Let's just talk about transformations here. Let's talk about everything that's going to happen. We know what the cotangent graph looks like. You take your tangent graph and pretty much you flip it over. And that's going to be your cotangent graph. So let's take this, this equation up here. Y equals 0.3. So that changes your amplitude, right? Does cotangent have amplitude? No. No. It does not change your amplitude. It still stretches and compresses the same way it normally does, but it doesn't change amplitude. 0.3 times the cotangent of, I notice I've got a 2 in front of that x. Needs to be factored out. But we've got to figure out what we multiply 2 by to give me pi over 2. And if you need to go through this, if your brain just for some reason is not working right one day, and honestly I still have to do it. If I say, okay, I've got to figure out 2 times what is pi over 2, what is that? 2 times something is pi over 2. That's an equation. What I just said is an equation. And I'm trying to figure out what that something is. Well, how do you solve that equation? Divide by 2. You multiply by half. So 2 times what is pi over 2? Pi over 4. That makes sense. Anytime you can't think of what that number is, just set you up a little equation and ask yourself, what would I do to solve this equation? So here's all your transformations. This graph has been what? Compressed vertically. Because again, notice vertical because it's not inside here. This is a vertical compression times 3/10. So vertical compression times 3/10. Oops. 0.3. That's one of your transformations. What does the 2 do? Horizontal compression times half. That's your second one. What does the pi over 4 do? Yeah, and they actually call it a phase shift. A phase shift left 45 degrees, if you want it in degrees. There's all your transformations there, and here's your actual graph. I don't know if I've graphed the original now. Again, the way that you would graph that, just plug in some x values. Okay, plug in some x values, use your calculator, crank out some y values. That's what's going to happen. It's going to be compressed vertically. It's going to pretty much make it shorter. It's also going to compress it horizontally, which honestly, those two right there, I nearly picture undoing each other. Because one of them makes it shorter and the other one kind of pushes it in, which is actually in essence going to make it taller. So those two kind of undo each other a little bit. And then it's been moved left 45 degrees. Okay, next up, inverse functions. Reminder, we've done inverse functions several times this year, but this is one of the things that we tend to forget. X plus 3 equals 7. We use inverse functions to to solve equations. In this case, the inverse function of plus 3 is minus 3. Plus and minuses are inverses. Multiplying, dividing are inverses. Squares and square roots are inverses. We've actually, back when we first started this chapter, we did the inverse of sine and cosine. Sine of x equals 1/2. To solve an equation that involves sine, okay, x is your argument. To move sine over, you do inverse sine, is actually what it's called. Or sometimes it's called arc sine. To get rid of cosine, you do inverse cosine or arc cosine. To get rid of tangents, you do inverse tangent or arc tangent. So inverse functions, review what is an inverse. And here you see a picture back from previous chapters. If your original function carries you from A to 3, from B to 1, C to 2, then your inverse function goes backwards. Graphically, here's what an inverse and a function looks like. If your original function in red looks like this, you have this line. Does anybody remember what this line is? That's your y equals x line. Because think about what you do to find the inverse. Don't you switch your x's and y's? Your function and your inverse function will be mirror images of each other. It's going to be a flip across that line y equals x, a perfect mirror image. So there you see a picture of a function and its inverse. So keep that in mind as we go through these. So what is the problem with inverse trig functions? Let's think about this. To solve this basic equation, I've got to move sign over there. Back when we were solving Sokotoa problems, simple right triangle problems, we moved sign over there by doing inverse sine, and what did we get as an answer? Sine of what is 1/2? We'd do inverse sine of 1/2, and we would get, y'all know that one, 30 degrees. Does anybody see an issue with that now? The sine of 30 does equal 1/2, that's true. But is that the only value that gives us a sine of 1/2? What's the sine of 150? And it'll have to. Because you're in the second quadrant. Your sine values, if you do, all students take calculus. You're in the second quadrant, your sine values are still positive. From 30, what's my reference angle for 150? 30, right? So would I not get the exact same value there? 390? 510, I think. What's the sine of 390? 1/2. What's the sine of 510? 1/2. What's the sine of negative 330? 1/2. So do you see an issue here? If I ask you the sine of what angles equals 1/2, is the inverse of that a function? No. Because sine of 30, we're good there. That's a half. Sine of 45, root 2 over 2. Only root 2 over 2. That is a function. Y equals the sine of x is a function, but unless we fix this, its inverse is not going to be a function. So how can we fix this? A lot of times we'll do what's called restrict. We restrict our domain. And that's what your calculator does. Because think about it. If you type in the inverse sine of 1/2, does it give you all those answers? It gives you one. Okay? And that's what we're going to do here is we're going to restrict our domain to where, and that's what your calculator has done. It says the inverse sine graph, or the inverse sine function. Notice it calls it a function. But we know that if you do inverse sine, you've got multiple answers there. So what we're going to do, the function y equals inverse sine of x, or y equals arc sine of x, is the inverse of y equals sine of x restricted to this domain. And the domain, or the domain of the inverse sine, we know that would be the range of your original, would be negative 1 to 1. For cosine, notice they restrict your cosine to a different domain. And the reason we restrict it, I wish I had the original graphs here. Let's look at our sine graph. There we go. There's your sine curve. And if I ask you one more time, 1/2. There's about 1/2. The sine of what value is 1/2? Well, the sine of 30 is a half. The sine of 150 is a half. The sine of 390 is a half. The sine of 550 is a half. So you got all these answers. So what are we going to do? Here, look back up here. What do we restrict sine to? Negative 90 to 90? All right. Yeah. We're going to say, okay, from negative 90 degrees, we're only going to use this part of my graph. And I don't think they included, yeah, from negative 90 to 90. We're only going to use that part of our graph. That way, actually not even that, is it? My bad. Let's try that again. We're only going to use this portion of our graph. Right? And that's the answers. Once you type in the inverse sine of 30, the inverse sine of 0.3, the inverse sine of 0.2485, they're going to give you an answer from here to here. Now, it's going to be up to you if you need those other answers to know that, well, I could take part of my answer, or could take my previous answer and find an answer a period later. I could take my answer and find an answer that's going to be in a different quadrant. Okay, that's going to be entirely up to you. But here's what you need to know. Inverse sine is restricted from negative 90 to positive 90. Inverse cosine is restricted from 0 to pi. And inverse tangent is restricted from negative 90 to positive 90, the same as sine, except for we don't include negative 90 and positive 90. If you think real hard, you probably know why. You can't find the tangent of 90, right? It's undefined. And we should be able to have all of our answers. Now, why are they restricted to different things? Why can we not restrict, let's look at it like this. Why can we not, we restricted sine from negative 90 to positive 90, from here to here. So if we type in the inverse sine of 0.3 something, we're going to get an answer up here. If I type in the inverse sine of negative 0.2, I'm going to get something down here. Do you see why I can't restrict cosine to those same things? If I type in the inverse cosine, let's say it was restricted to this, the inverse cosine of 1/2. If it were restricted to these two quadrants, what answers would you get? The cosine of what gives you 1/2? Is it 60? Is that the only answer it would give you? Isn't there another answer here that's also got an inverse cosine equal to 1/2? And I believe it would be, let's see, 60 degrees, that's 30 away, 300 degrees. We're trying to restrict this thing to where it is a function. But there, if you type in the inverse cosine of 1/2, if it were restricted to the same negative 90 to positive 90, you still got two answers. But now here, and this is the whole key. Sine is positive here, sine is negative here. So that covers all your possibilities. Cosine is positive here and negative here. That covers all your possibilities there. That's the reason they have different restrictions. Sine's restricted from negative 90 to positive 90. Cosine is restricted from 0 to 180. Okay. So with all that, give the radian measure and the degree measure. What we want you to do here, knowing where our restrictions lie, we want you to tell us where this is gonna, what calculator answer this would give you. We know that if we're doing the inverse sine, that our answer, our calculator, our restricted answer is going to be between negative 90 degrees and positive inclusive. Negative 90 degrees and positive 90 degrees. It's going to be in that interval. The inverse sine of root 2 over 2. Again, we're asking ourselves the sine of what is root 2 over 2. And since we don't know them all that well yet, I'll let anybody give me the answer here. Since it's positive, is it going to be in the first quadrant? Because this is first quadrant here, and this is the fourth quadrant here. It's going to be in the first or fourth. First, because it's positive. And what is what sine value gives me root 2 over 2? 45 degrees, or pi over 4. I'm going to give it give the radian degree measure. The second one, the inverse sine of 1/2. Same thing, we're restricted from negative 90 to positive 90. What value of sine is equal to 1/2? 30 degrees. Or pi over, questions? Arc sine of 0. I believe the sine of 0 is 0. 0 degrees or 0 radians, same thing. And notice the last one, the arc sine of negative root 3 over 2. Got to be careful on this one. Because what am I going to want to do? I'm going to want to give me like a 300 degree angle. We're not defined 300 something degrees. We're only defined from negative 90 to positive 90. Now, if it makes you feel more comfortable, you can change it. Put the 300 degree down, subtract off a rotation, that's fine. But what's my reference angle there? 60. The sine of 60 is root 3 over 2. So we know that a 60 degree angle has a positive root 3 over 2, but we need a negative root 3 over 2. So that would be Negative 60 degrees, which is the same thing as 300 degrees. They're identical. So therefore, arcsine of negative root 3 over 2 would be a negative 60 degrees or negative pi over 3. Let's do the cosine ones. Cosine, well, or not. Thought I had some cosine ones on there. There we go. We'll do those later. Here's one of the ones that are not common, which you might actually like these better because you didn't have to memorize them. Let alpha be an angle between negative 90 and 90. Again, that's our where we're defined at, from negative 90 to 90. In each case, find alpha to the nearest tenth of a degree. You've done these, okay? But what I want you to keep in mind now is you know what quadrant it's going to be in before you even type it in. You know if your answer is going to be a positive angle or a negative angle before you even type it in. Sine of alpha equals 0.88. To solve that, we're going to do the inverse sign. And keep in mind that my calculator is going to be restricted when I do the inverse sign, and it should give me an answer in the first quadrant. It should give me a positive answer. Somebody's got that typed in. Round it to the nearest degree, or actually nearest tenth of a degree, and tell me alpha, what it's equal to.
61.6.
61.6 degrees. And the more you do of this, hopefully the more comfortable you get, the closer that your sine value gets to 1 whole. Think about what we know now. The closer your sine value gets to 1 whole, the closer you're going to be to 90 degrees. So you can kind of estimate these. Start estimating now. Does that sound right? Because 0.88 is pretty close to a whole. The sine of 90 degrees would be a whole, so we should be approaching, getting pretty close to 90 degrees there. And then the second one, the sine of alpha equals negative 0.27. So the inverse sine of negative 0.27, we should be in the fourth quadrant because that's where sine is negative. So alpha is going to equal a negative 15?
15.6 degrees.
Negative 15.6 degrees. Which should make sense. And if you don't want a negative answer, okay, again, your calculator is restricted to just negative 90 to positive 90. That's the only answers you will ever get. If you don't want that negative answer, tack on 360. Add 360 to it and give you, which I should have put squigglies there. It's not equal. 344.4. But again, look what they wanted between negative 90 and 90. I'm just letting you know, later on, if you want those other answers, tack on a rotation. Okay? Get you a positive one. That's enough of those. Here's your cosine ones. As you're working with cosine, remember that cosine is restricted from 0 to 180. That will cover every range of answers you could possibly get. Because we know in the first quadrant cosine is positive, in the second quadrant cosine is negative. That's all the possible values that you might find the inverse cosine of. These are your common ones. We should know these, right? Inverse cosine of negative 1. The cosine of what value between 0 and 180? That's the only ones we're dealing with. Cosine's positive, cosine's negative. Cosine of what is negative 1? 180 degrees. Or pi. The cosine of what is negative 1/2? First, determine are we in the first or second quadrant? Second, so therefore it's going to be bigger than 90. So now we can look at a reference. We're in the second quadrant. Take away the negative. The cosine of what is 1/2? Well, first off, cosine of what's 1/2? That'd be 60. So we need our 60-degree angle that's in the second quadrant, and that would be, like you said, 120 degrees. Because that has a reference angle of 60. Now let's try to change that to radians, just to where we can give degrees and radians. Take pi, divide it by something that we can divide into 120. How about pi over 3? What's pi over 3? That'll go into 120, right? How many 60s is in 120? So 2 pi over 3. And then the last one, the inverse cosine of root 2 over 2. We're in the first quadrant because it's positive. Cosine of what's root 2 over 2? Or pi over 4 as a radian. Another calculator type problem. Cosine of alpha is 0.23. Since we're positive, we know that we're going to be somewhere in the first quadrant. You'll simply type in inverse cosine to get rid of your cosine there. and you're going to get a value of nearest 10, 76.7 degrees. And again, notice first quadrant. The second one, before we even work it out now, we know our answer is going to be bigger than 90, smaller than 180. We're somewhere in that second quadrant because that's where cosine is negative. We type inverse cosine in, and we get alpha is about 145.1. Remember, though, that is not the only answer. That's because we restricted our domain to where your calculator will not blow up whenever it tries to give you an answer. Because if you didn't restrict it, I mean, that's kind of where we're going with. If you didn't restrict it and you told your calculator, okay, tell me where the cosine is negative 0.82, it would be in an endless loop. Does that make sense? It would never stop because it would keep cranking out answers. Okay, to blow up. So that's really it. That's why we restrict domain. Let's do the same thing with these tangents, secants, cosecants, cotangents. The inverse tangent of 1, we're simply asking ourselves, now with tangent, remember that tangent is restricted from negative 90 to positive 90 as well, but they don't include it. Tangent and sine have the same restrictions. Cosine is the only one that's restricted from 0 to 180. So we're asking ourselves the tangent of what is equal to 1. Could I type it into my calculator? Yeah, honestly. What is that answer? 45 degrees. Or pi over 4. Arc secant. You don't have to memorize these. Secant is going to have the same domain restriction as cosine. Cosecant is going to have the same domain restriction as sine. It's the same thing. So since this is the same as cosine, we're looking for something between 0 and 180. Now, we've got to be careful. The arc secant of what value is negative 2? Think about the relationship between cosine and secant. They're reciprocals of each other. Now, before, when I was finding the secant of 30 degrees, I did 1 over the secant, 1 over the cosine of 30 degrees, right? I flipped the whole value. When you're doing the arc or inverse secant and the arc or inverse cosecant, you don't flip the whole thing, you flip what's in the parentheses, which pretty much is the answer to this whole thing, okay? So to find arc secant, you're going to do inverse cosine of the reciprocal of that, negative 1/2. Flip what's in parentheses when you're dealing with arc and inverses. And that's going to be, let's see, from 0 to 180. We're in the second quadrant since we're negative. What's that going to be? 60 is your reference, so that'll be, since you're in the second quadrant, 120 degrees. Wow. To find the inverse cosecant of root 2, that'll be the inverse sine of 1 over root 2. Or the inverse sine of, when you rationalize that, do you see why rationalizing is so important now? Root 2 over 2. Because you probably don't know what the inverse sine of you probably don't know what the inverse sine of 1 over root 2 is, but when you rationalize that, root 2 over 2 looks much better. Inverse sine of root 2 over 2 is positive. We're looking for an answer between negative 90 and positive 90. What's your answer? 45 degrees. And the last one, arc tangent, which is the same thing as the, inverse arc cotangent, which is the same thing as the inverse cotangent. We're going to reciprocate and just find the inverse tangent of, I'm glad they did that, aren't y'all? Negative 1 over root 3, we reciprocate that to negative root 3. Tangent is defined from negative 90 to positive 90. So what quadrant are you going to be in here? It has to be either, let's see, all students take calculus. There's where you restrict tangent to. So since it's negative, it should be somewhere down here. What's our reference angle? The tangent of what is root 3? 60 degrees. But since we're in the fourth quadrant, since you have a negative, instead of being 60 degrees, it'll be negative 60 degrees. So just a reminder, these are the ones that you don't know. These are the ones you type straight into your calculator. Inverse sine of 0.88. I know when I type that in, since sine is restricted to first and fourth quadrant, since it's positive, I should get a first quadrant answer. Inverse sine of 0.88 is 61.6 degrees. Which again, if you don't know what we're doing here, you should be able to turn right around and type in the sine of 61.6 and get 0.88. We're working backwards and forwards. We're just going from angle to argument and then argument back to angle here. Inverses. The arc cotangent, you don't have that button on your calculator. You can look, you won't have it. The arc cotangent is the reciprocal of arc tangent. So what you're going to do is you're going to do the inverse tangent and you reciprocate this. The inverse tangent of 1 over 2.4. Should be a first quadrant answer. 22.6 degrees. Last two. The inverse cosecant. Cosecant is a reciprocal of sine. So you're going to do the inverse sine of 1/4. 14.5 degrees. And the last one, the inverse cotangent of 0, which would be the reciprocal, the inverse tangent of 1 over 0. Now let's think about that. Yeah, 1 over 0 is undefined, right? But my question is, will that have an answer? There you go. Because this is undefined. So you've got to ask yourself, where is tangent undefined? 90 degrees, but again, like we said, we're restricted from 0 to 90. We know what our angle is. Okay, we know it's a 90-degree angle, but since that's not in our domain, we're gonna throw it out. We can't find the tangent of 90, but we know what that angle is going to be. We knew what our answer would be, even though we can't find the tangent of 90.